Alright, let's now look at expected value of a random variable. Yeah? So we have a random variable x. What is the expected value? The expected value is basically a weighted average over a large number of experiments. Yeah? Intuitively, you could see it as a center of gravity. Yeah? So I have an example here. Let's define the expected value of x, yeah, equals the sum over x, yeah, of px times x. Yeah? So this is the value of the random variable times the probability of occurrence. And this is exactly what we do in probability distribution. This is a discrete probability distribution, and we also call this a probability mass function, because you can see these dots as weights, yeah? And the center of gravity will point here where, you know, left and right you have the same balance. So if we calculate this for our example, then it is x is 1 out of 6, yeah, times, and there's 1 point here, okay, plus x is 1 out of 3 times, there's 4 points here, plus 1 out of 2 times, and there's 2 points here. And you calculate this and you end up at 2.5. Now that's the expected value. Okay, so keep this in mind as we're gonna calculate this for a number of well-known distributions. Now there's some characteristics of expected value that we should know. Yeah? So alpha and beta are just real numbers. They're elements of R. The expected value of a number, alpha, is alpha. Yeah? If I give you a number 5, the expected value you're gonna get is 5. Yeah? So that's alpha. The expected value of alpha x, we can put the alpha outside of the expected value and keep x only. And then this is linearity. This is the same as expected value of alpha x plus the expected value of beta. Yeah, and this we have seen, that is alpha expectation of x plus beta, because the expectation of beta is just a number equals beta. Alright, let's now take a look at the variance. The variance of a random variable x, yeah, is basically give you an indication of the spread of your data set with mu as a reference point. And what is mu? Well, mu is the expected value of x, which we've just seen. So the formula is the spread, right? Is the expected value of x minus expectation of x. Yeah. So and this we're gonna square. No? So the fact that we square proves that the variance of x is always positive. Yeah? So the expectation of x is mu, so it's the same as x minus mu squared, and is the same as expectation of x minus mu times x minus mu transpose. Yeah, we've seen this already many times. And is also the variance of x, another way of writing it, is the expectation of x squared minus the expectation of x squared. Yeah, so these are all the formulas of variance. What you need to know is that the variance of x is also a random variable, we see it's positive because of the squaring. What's the variance of alpha x plus beta? Again, with alpha and beta, elements of R. Well, we can easily calculate that. The variance of a fixed number is 0, because 5 does not vary, it remains 5, yeah? So, but the alpha we can take out, but we need to square it. So it's alpha square variance of x, yeah? Just don't forget to square here. Okay, that was it for variance.